So let's identify each of the following molecules as polar or nonpolar. You remember, we're looking at molecules here. Okay, so this is our first one. This is carbon dioxide. I've got the Lewis structure written out for you. We have a central atom with two bonded pairs and no lone pairs. So the Vesper form would be A, B2 for our two bonded pairs. And that, if we look on our table, gives us a linear structure. Okay, so our note beside polar says no if symmetrical. And the reason for this is this bond is a polar bond. Carbon is much less polar and much less electronegative than oxygen. So there's a dipole moment here, but there's also a dipole moment over here. And they cancel each other out. So as long as the molecule is symmetrical, it is nonpolar. Okay, our next molecule we're going to look at is H2O. So H2O, this is the Lewis structure for it. We look at the central atom here. It's got two bonded atoms to it, so we'll B2. The central atom has two lone pairs that are non-bonding lone pairs. If we look on our table, this is bent. So I've drawn it straight, but that's not really the way it should be drawn. It should really be drawn bent, like this. And there is a dipole. There is an electronegativity difference between oxygen and hydrogen. The oxygen is more negative. And they don't cancel like they did here. They were end to end. Here, they're both kind of pointed that same direction. The molecular dipole is going to be like that. And so this molecule is polar. Our third molecule is ammonia. If we look at the Lewis structure that I've drawn here, we see that we have a central atom. We have three bonded atoms and one non-bonding lone pair. If we look on our table, we see that this is trigonal pyramidal. And we also see that if the bonds are polar, the molecule will be polar. And there is an electronegativity difference between this. Nitrogen is more electronegative than hydrogen. And so we have a polar molecule here. This is not drawn properly. To draw it as a trigonal pyramidal, you would need to put the nitrogen in. The hydrogens all down in a trigonal pyramidal shape, and then our lone pair on top. So let's look at the carbon tetrachloride. Got a central carbon, and we've got 4 bonded atoms. We have no lone pairs on the central atom. The central atom is the only one we care about having lone pairs on. So if we have lone pairs everywhere else, it won't matter. If we look on our table, this has the tetrahedral shape. And it's symmetrical. So if it's symmetrical, it will be nonpolar. Okay, so let's look at this one. This also has a central atom, carbon, 4 bonded atoms. That makes it tetrahedral. But it's not symmetrical. We're going to end up with the chlorine's going to be more electronegative, so we'll draw our bond dipoles in. These three are all pulling in one direction, so you're going to end up with a polar molecule. The dipoles are not going to cancel because we have a hydrogen up here that's not a chlorine.